Hi, this is Mrs. Robertson, and today is Tuesday, September 3rd, and we are going to be doing our math boxes located on page 38. So please find page 38 if you've not already done so, and I'm going to go over the answers to today's math boxes. So here are the answers to the math boxes for lesson 110. This is a preview of what you're going to be doing in Unit 2. So let's go over this. You should remember a lot of this from 5th grade. Find all the factors and the first four multiples of 36. Factors are the numbers that you put together to get 36. Well, 1 times 36 is 36. 2 will divide 36 18 times. 2 times 18 is 36. See how I put them on the different ends of the lines here? Will 3 divide 36? Yes, it will. 3 times 12 is 36. Will 4 divide 36? Yes. 4 times 9 is 36. Will 5? No. Will 6? Yes. 6 times 6 is 36. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Now, the second part, it wants us to list the first four multiples of 36. The first multiple of 36 is 36 times 1, which is 36. The next multiple, 36 times 2, is 72. The next one will be 36 times 3, and that gives you the product of 108. And the fourth multiple of 36 is 36 times 4, 144. So the first four multiples of 36 are 36, 72, 108, and 144. Let's look at the box number 2 and discover what the answer is for this one. One pinball game costs 25 cents to play. How much will it cost to play 10 pinball games? Well, you can multiply 25 cents times 10. 0.25 times 10, or you could add 25 cents 10 times. Put down a place value 0. Now, how many numbers are behind the decimal point in the problem? 2. So it will cost $2.50. Math box number 3. Change the mixed numbers to fractions, and they are wanting them to be improper fractions. Write the word improper above fractions. And to do that, you're going to multiply the denominator times the whole number. 10 times 4 is 40. Add the numerator and put it on top of the denominator. You multiply, add, and put it on top. 8 times 1 is 8, plus 7 will give you 15 eighths. 4 times 8 is 32, plus 3 is 35 fourths. 2 times 6 is 12, plus 1 is 13 halves. Any questions? In math box 4, they want us to find how many inches are in 7 feet. There are 12 inches in 1 foot, so to figure out how many inches are in 7 feet, you multiply. 12 times 7 is 84. There are 84 inches in 7 feet. 9 times 12, we're changing feet to inches. 12 times 9, 18, carry a 1. There are 108 inches in 9 feet. Now, to change inches to feet, you're going to divide by 12. There are 12 inches. So 42 divided by 12. 12 will go into 42 3 times. 3 times 12 is 36. Subtract. And you have a remainder of 6. So it's 3 6/12, which will equal 3½ feet. How many inches are in 5 feet? Again, we're going to multiply by 12. 12 times 5. There are 60 inches in 5 feet. Now let's go on to question number 5. In question number 5, it says to estimate. Okay, 7/8 is almost 1, and 5/6 is almost 1. It's going to be close to 2. Less than a half? No. Between a half and 1? No, it's going to be bigger than that. Between 3/2 and 2? It's that one. It's not going to be greater than 2. So the answer for number 5 will be C. Let's go to number 6. In problem number 6, Jacqueline was playing marbles. After playing 2 rounds with her friend, she had lost a third of her marbles. She started with 12 marbles. How many marbles did she have left? Okay, well, let's draw 12 marbles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, if I take that and I put it into groups of 3, that would be 12 divided by 3 would be 4. So there's 4 in this group, 4 in this group, 4 in this group. Okay, so she lost a third of her marbles. How many marbles did she have left? She has 8 marbles left. All right, now we're going to start our lesson and we're going to go to page 35, kids. So turn your book to page 35. We're going to read our math message here. And this again introducing negative numbers. Alyssa went to the doctor's office for her annual checkup. She made several stops. On the number line, plot a point for each floor she visited and label it with its letter. Now, I am going to read this and I want you to plot the point where it belongs. The ground floor of the building is 0 on the number line. A, you're going to put an A where Alyssa entered the building at ground level. Put an A where Alyssa entered the building at ground level. That would be considered 0. Make sure you put an A there now. B, she took the elevator to the doctor's office on the 2nd floor. The 2nd floor, you're going to put the letter B. Letter C, she went down to the lab, located in the basement 2 floors below ground level for a blood test. Put letter C where you think that one should be. And letter D, she took the elevator to the 5th floor to have x-rays taken. Put letter D. All right, so you should have C with -2, and D should be up here with a 5. If you do not have that, put it on your paper now. We should be ready for question number 2. Mr. Pima's class planned a raffle. 3 students sold raffle tickets. The goal for each student was to sell $50 in tickets. The table below shows how well each of the 3 students did. Complete the table. If you are $5.50 short of the goal, you are negative $5.50. Okay, if you're short, that means it's going to be negative. That short means it didn't quite make it, so they still need more money. If you met the goal exactly, it's at $0. Let's put a dollar sign in on this one. If you pass the goal by $1.75, you are at $1.75. That would be considered above the goal because you've passed it, you've exceeded it. And when you don't need to put a plus sign in front of it, because if there's no plus sign, it's considered positive. Describe a situation in which you can use positive and negative numbers. Use examples to explain positive, negative, and 0 in your solution. Temperatures. That would be one. You have temperatures above and below 0. Football. You could write an example with football. You can gain and lose yards. When you lose yards, it would be negative. Temperatures, we have positive and negative temperatures. All right, money. You can lose money or you can owe money. When you owe money, that's a negative. All right. If you lose money, that would be considered a negative. All right, now I want you to take time and put some positive and negative numbers. Positive numbers would be to the right. Negative numbers would be to the left. You can always look at the number line under the screen in the wall in my classroom to help you if you need help with that. Okay, once you're finished with that, we're going to go to page 36. So let's turn to page 36 and look at what we have here. Expanding the number system. You may have seen Venn diagrams before. Study this one, which shows how some numbers fit into categories. If one circle is inside another, the numbers in the smaller circle must belong to both circles. Use the examples in the information in the student reference book to help you place these numbers in the diagram. Okay, -35 is with integers. So put -35 in the integer circle. So we have the counting numbers. Those are numbers that don't include 0. Whole numbers are 0 and all the counting numbers. Integers are positive and negative numbers that are counting in whole numbers. So you have the counting numbers, the whole numbers, and the negatives of the counting numbers. Rational numbers include fractions and decimals. Rational numbers include fractions and decimals. All right, now 56 is a counting number. 5½ is going to be a rational number. It's going to go in this circle. -8/10, that is a decimal. It goes in the rational number group. -7/8, it's a fraction. It's going to go with the rational numbers. 1,000 That's a counting number. -4 is an integer. Okay, make sure you have your numbers in the right spots. Problem number 2. For each number, circle all that apply. Okay, you can use this diagram to help you if you need help to go over the answer. -25. It's not counting. It's not a whole. -25 is an integer. And it would also be considered a rational number. One and 5/8 is a rational number. -5 and 92/100 is a rational number. Kids, I am looking at the Everyday Math Answer book, and it says -25 is a rational number, but it is not, it doesn't have a decimal, so let's just not circle that one, okay? Because it would go in this circle right here, wouldn't it? Yeah, it sure would. 4 is a counting number. 4 is a whole number. Oh, I know now why they were, because rational numbers include all of these. So, yeah, go ahead and circle that one. Mrs. Robertson messed up on that. All right, 4 is a counting number. 4 is a whole number. 4 is an integer. And 4 is a rational number. All right, now let's go to the next part. Use the clues to find each mystery number. Read them. You can put me on pause. Read them, see if you can get them right, and then you can go ahead and play it to see if you got the answers correct. Welcome back. It is an integer, but not a counting number, and it is closer to 0 than to -3. It's going to be -1 because it's closer to 0 than -3. -2 would be closer to -3 than 0. Let's try this one. It is a rational number and a whole number, but it is not a counting number. It's 0. It is a rational number and a counting number. It is greater than 2 and less than 4. Well, the counting numbers that are greater than 2 and less than 4, it would be 3. Any questions? All right, now let's see how good you are at doing factors and multiples, and then I will give you your homework to do for tonight. Okay, the factors of each one. The only way you can get 13 when multiplying is 1 times 13. When it has exactly 2 factors, it's called a prime number. Write that down on your paper in your math journal. Factors of 30. 1 times 30, 2 times 15, 3 times 10, 4 won't go into it, but 5 times 6. Write that down. Factors of 42. 1 times 42. It's an even number, so you know 2 will divide it. 2 times 21. Will 3 divide it? There's a secret little test to see if 3 will divide a number. 4 plus 2 is 6. Will 3 divide 6? Then 3 divides this one. 3 times what will give you 42? 14. 3 times 14 is 42. 4 won't go into it. 5 won't go into it, but 6 times 7 is 42. 21. 1 times 21. Will 2 divide 21? No. 3 times 7 is 21. Let's do number 2. Adrian has 75 baseball cards. He wants the same number of cards in each pile. How many cards can he have in each pile? All right, in this problem, we're going to find our greatest common factor. And with this one here, you're going to do, well, there's more than one answer you could have here. You could have one pile with 75. You could divide it by 5 and have 3 piles of 25. Oh, 5 goes into 75. You could have 5 piles of 15. And there are more that you could have, but those are some suggestions of 15 cards. List the first 5 multiples of each number. So 3, you're going to multiply it by 1, 2, 3, 4, and 5. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Let's do the same thing for this one. 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. 10 times 4 is 40. 10 times 5 is 50. Let's do letter C. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4, 48. 12 times 5 is 60. 17 times 1 is 17. 17 times 2 is 34. 17 times 3, 51. 17 times 4, 8, carry a 2, 68. 17 times 5, 85. Hope I got those right. All right. A Ferris wheel makes a full rotation every 80 seconds. How many seconds will it make a second rotation? All right. Well, that's just going to be 80 times 2, but you can put the little dot, equals 160 seconds. A third one, 80 times 3 equals 240 seconds. A fourth one, 80 times 4, 320 seconds. A fifth one, 80 times 5, 400 seconds. Explain how a factor is different from a multiple. A multiple is the product of a counting number and the original number. This is a symbol for, this is the symbol for and. A factor is a number you multiply. Let's see. A factor is a number you multiply to get the number, or another way to think of it is a factor is a number you can divide into your number without a remainder. All right, now, once you're done with this, you're going to get your worksheet, and that is going to be your homework tonight. You are going to do both sides of the worksheet. It should be pretty easy. This is the worksheet you're going to get. On the first part, it says indicate whether each statement is true or false. Circle true or false. In part 2, circle all the numbers that belong to each number set. Integers, counting numbers, rational numbers, whole numbers. You can always go back to your math journal page to look at the Venn diagram. Or you can look at this video if you forget to bring your math book home. Here's the Venn diagram. That will help you with identifying which numbers you need to have. And the same thing with number 3. You can use this diagram to help you with that. Once you're finished with this side, do the back side. It's very friendly. You'll be getting your home links later this week. Put the letter on the number line that would match. Negative 57 degrees is in between negative 50 and negative 60, closer to the negative 60. Put a dot, and that's letter A. So you've got that one finished. And the same thing here with the tree trunk. This is called a vertical number line. Lowest branch at 6 feet. Well, this is going to be the 6 feet and put an M. Okay? And then don't forget to do the 2 problems at the bottom. Have a good day. I will see you tomorrow.